Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 80, I chat with Laurie Fincham, Senior Vice President of Audio Research and Development at THX, about the pursuit of high-quality audio. So stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Home Theater Geeks is provided by Cachefly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, recorded September 19th, 2011. Episode 80, Speakers and Amps and Line Arrays. Oh my! This episode of Home Theater Geeks is brought to you by Netflix. Watch thousands of TV episodes and movies on your PC, Mac, iPad, iPhone, or TV instantly. All streamed directly to you, saving you time, money, and hassle. For your free 30-day trial, go to netflix.com/twit. Hey there, Scott Wilkinson here, online editor of hometheater.com. And this week's guest geek is Laurie Fincham, Senior Vice President of Audio Research and Development at THX. Hey, Laurie, welcome to the show.
Hi, Scott. Thank you.
So happy to have you here. Those who are tuned into the live video stream at live.twit.tv or signed into the chat room at irc.twit.tv can post questions for Laurie during the show, and I'll pass along as many as I can.
Oh.
So, Laurie, watch out. We're going to get some questions from the chat room, I am sure. So, I'm happy to say that both you and I are performing musicians as well as audio geeks, and at the low end of the frequency range, not even better.
Well, they're my initials, LF, you see.
Oh, yes, of course. But you do more than LFE, I would say.
I do, yes.
No, you're a stand-up bass player, as well as a stand-up guy.
Yes.
Do you play much these days?
I play on my own occasionally, you know, when I'm in the mood, but I'm thinking of getting one of those Yamaha pianos that can record everything for me, except the bass, and then I can play along with it.
Oh, that's a good
slightly
idea.
More fun.
Yeah. Slightly more fun than just playing the bass all by yourself.
Yeah.
And you played mostly jazz in your day, as I recall.
Jazz trio, and sometimes with sax players, yes.
Mm-hmm. You and John Atkinson actually share exactly that same.
We do, although I think he went the way of all flesh and got a bass guitar, which is not really the same.
No, it's not. You don't play the electric bass?
I only did when mine fell over and broke.
Well, I have to ask you, as a musician, I'm asked this all the time as a musician, which is, are you an audiophile? Do you consider yourself an audiophile?
I think the answer is I was when I was much younger. Yes, I think so. I was at the period when we were just beginning to go away from 78s to LPs, and so I really did mind about the sound quality. I think when I did it for a living, I stopped. I was only an audiophile at work, but not at home. I decided if I couldn't listen to Charlie Parker because the recording quality wasn't very good, there was something wrong, and I stopped fussing about it at that point.
Yeah, I have to say I feel the same way. I'm surrounded by live music so much that that any reproduced music just doesn't quite make it in terms of being compared to live music.
No, well, it's also a social thing when you're playing. You know, there are other musicians, and there's the atmosphere of being there. And perhaps sometimes recorded music is a little sterile from that respect. But I shouldn't be too judgmental because I spend such a lot of time just listening to LPs and CDs that I just like it all. That's all.
Indeed. Well, it certainly brings up one of the issues that I wanted to chat with you about today, which is that the audio industry seems to have been long headed towards convenience and away from quality. Now, granted, you and I both can hear the difference even in a high-quality audio system, but between that and live music, I should say. But still in all, you and I are both concerned about quality audio reproduction. And I'm a little disturbed by how consumers seem to care about high quality. What do you think?
Well, I think the love of high-quality sound was always, relatively speaking, a minority interest. If you take the population as a whole, now, of course, it's all down to getting as much program as you can to somebody for as little money as possible. I think, though, that it's up to us, those who like and love music and listening to good quality, to expose more people to it. I mean, if you don't have somewhere where you can go and listen, and typically you can't so much, even at retail, you can't go and listen. Quite often you're just staring at a box on the shelf and walking away with it afterwards. I think we can do more to expose people to good quality music, and once they see it and hear it, I think it'll be like good wine or good food. You know, you just hope you don't get to like it too much because it's going to cost you a lot of money.
Well, how do we get people exposed with the demise of the small hi-fi shop and the rise of mostly big box stores like Best Buy and even internet shopping where you can't hear it at all?
Well, I don't know. I mean, I think when I used to be in the speaker business, we used to spend a lot of time actually going to dealers and doing, having dealer evenings where we'd have all our stuff on show and we would talk to them. Maybe you need an equivalent of that. Maybe you can do a sound demonstration in a store, but perhaps it isn't click the box. Perhaps a manufacturer goes along and does an evening with really good music, somebody who understands the business and likes it. I think that might be one way of doing it. At the moment, it's too informal. You just go in and click around. You have no idea what you're listening to or whether it's good or bad, and quite often there isn't even anybody there. So maybe the manufacturers have to take that role. They're the evangelists, after all, for what they do. You could do that. I don't know whether you'd ever have music clubs where you could go and listen to good music. I mean, we used to do that when I was younger. We'd have like a British Sound Recording Association where we play our own recordings, and that's probably quite a good thing to do. I think if you are a keen sound recording person, to be able to play stuff that you've recorded back to other people. I don't think we can absolve ourselves of the responsibility. We may regret the way it's going, but I don't think we have to give up. I think we just have to do more about it. That's all.
Certainly there are online resources to read about stuff. Jam Handman in the chat room is saying AVS is a good place. The AVS Forum website is where many geeks like us congregate and talk about audio and video quality. And another thing that came to mind was hi-fi shows. Stereophile used to put one on called the Hi-Fi Show, Home Entertainment Show. But I'm not sure how good the systems sound when they're played in hotel rooms. Have you been involved with that? I've forgotten now.
Yes, I've done a few thousand shows in hotel rooms over my time. No, it is a bit of a crapshoot in a hotel room, and you've got to get the show on the road. It's not the best place to do it by any means. Quite often, you're better off in being in a slightly larger environment where you don't have a close proximity to the walls. And typically in a hotel room, there isn't much on the walls. There'll be windows, and you're trying to stop flutter echoes being audible and that sort of stuff. So it's difficult to do, even when your own company is involved in the business. Making and designing your own listening room and keeping it in a state that you can play music is actually quite difficult. Plus, of course, people are not really listening so much to music now as they are to film soundtracks. So I guess that's one of the reasons why perhaps there's less emphasis on the absolute quality, because who knows what the soundtrack was supposed to sound like, particularly when a lot of it is manufactured or consists of explosions or car chases and so on. It's exciting, but there is no comparison. You can't say, oh, that sounds like an explosion, because most of us hopefully won't have been involved in one, and if we were, we would know it didn't sound like that at all, because you can't get an explosion onto a soundtrack. So even the gunshot is spread out. It's a surprisingly quick and almost silent thing out of doors, but they spread it out and go instead of pip, something like that.
Right. Well, of course, THX is heavily involved in trying to make sure that what consumers hear at home and in the commercial cinema, that's how they started, as closely as possible reflected the content creator's intent.
Yes, that's true, and I would say that part of the work that we're doing at the moment is about designing or enabling designs that are good for music. I mean, the film soundtrack is one thing, which is a creation, but quite often music that's recorded is simply a recreation of the original. It isn't something that's created separately in the recording studio. And part of what I've been doing is working on some new ideas for amplifiers and so forth, because I was concerned that in the dash to make amplifiers either cheaper or smaller or not run as hot, sound quality was being sacrificed for lower cost, or trendy words like digital, for example. I mean, we talk about digital amplifiers. They're not actually, they're analog ones. They're more correctly called switching amplifiers. They are really quite difficult to make to the same performance level as analog amplifiers. And so part of what I've been doing is seeing if we couldn't make an analog amplifier that combined the best of the old and the new. And we have just done that, actually. We just had a worldwide patents granted on an all-analog amplifier that nevertheless has standing and dynamic dissipations that are comparable and in some cases even better than the switching design. So that's been part of our mission, if you like. It was designed with music in mind, and we'll should probably be on the road showing people maybe what the difference is, or that you don't have to switch if you don't want to.
Yeah, this is one of the topics I definitely wanted to get deeply into with you, because I saw this first with you at CES last January, and at that point it was a pretty prototypical stage. So I assume you've come quite a ways in the last 9 months, eh?
Well, we understand it better now, let's put it that way. Prototypes always work and you think you understand it. And then what we've been doing is really deciding what we're going to do with the technology. And it would be correct to say we've designed a internal combustion engine rather than a car up to now, and now we're looking for ways in which we can show it to people. The line array that we were talking about before, that arose because when we first started to make this line array, which eventually had up to about 100 separate power amplifiers in it, we found that when we used the typical receivers that we had around the lab for doing this, that we were burning up 500 or 600 watts doing absolutely nothing, because the standing dissipation in a Class AB amplifier, and to a lesser extent in the switching one, is still surprisingly high. It's of the order of somewhere between 2 probably and 15 or 20 watts per channel, whereas the amp we've done could be as low as 100 milliwatts, a tenth of a watt. So we've concentrated very much on the power that's dissipated at very low levels, because the amplifier spends more time at low levels than it does at high levels. Quoting efficiency with a maximum continuous sine wave may be interesting in the lab, but it is not representative of any known use of an amplifier. Typically, the peak to average ratio is actually quite high.
The peak to average ratio
of the signals fed to the speakers. You may need a lot of volts to deal with the peaks in the program material, but the average power being delivered is in fact very, very low indeed. And so it's what the amplifier does when it's delivering a fraction of its rated output that determines. People talk about efficiency. I like to talk about dissipation. It's what inevitably goes up as heat. You put energy into the system, or put power in, and you deliver some to the load, and the rest of it has to go up in heat. And the point about it is that a high standing dissipation is like having a car where you arrive at the traffic lights and you're still revving at 3,000 or 4,000 revs. Now, of course, we're going much more towards the idea of turning the engine off completely, and that would be the ideal with an amplifier. When it's not doing anything or not required to do anything, it really should be off. If it could come on instantly, or at least as fast as was demanded to keep up with the music.
And do these new amps of yours do that?
Well, they do, because we also have we've designed a new power supply as well to go with this, which is it's a form of switching power supply, but it doesn't use capacitors or inductors as the storage element. And so what happens essentially is that it will go from nothing to full output in about 20 microseconds or something like that. So you could actually have the thing just on a whisper low level, and then the moment the music comes along, boop, it's on immediately. That's without putting any delay into the program at all.
20 microseconds, certainly faster than anybody can hear.
Yes, well, yeah, I think that's probably fair to say, yes. So this is going to be a sort of exercise. We'll show people what we've done. We'll let people hear it. We'll let our customers evaluate it. So it will also go to our existing customer base, the ones that already use amplifiers. They were given an opportunity to try it out and see if it meets their needs.
Now, these amps, as I recall, are very small as well.
They're very shallow profile. They don't have any, because they don't have any large inductors and because they don't have any smoothing capacitors on them, they're very low profile. So the whole amplifier board is probably 3 or 4 millimeters, or just over 1/8 of an inch thick. So this leads to sort of interesting packaging options. Most devices now seem to be getting thinner, don't they? Whether it's iPads or MacBook Pros and so forth. So there may be some attraction for an amplifier that's a different shape, if you like.
And what kind of power do they generate? I don't know if you've mentioned that.
You can sort of do what you like. We're working on one now where the output power would be, say, 400 watts per channel into 4 ohms, something of that order. That really
400 watts?
Yes, that has to do with essentially how much heat sinking you want to put in, yes.
Right, which of course takes more room.
Well, it does if it's dissipating a lot of power, but these actually run rather cool, and you can play them, and we're also operating them with batteries as well. So the batteries, it's a bit like the old-fashioned digital multimeter, if you recall. You had it plugged into the line, but and it could be charging the batteries. But and with the batteries available now, you could probably run at what I would call respectable listening levels for many hours. Because, of course, we're not dissipating 400 watts. That's the short-term capability, which if you were playing at that level, it'd be so darn loud you'd be deafened. I mean, you're right up there in the high hundreds, in the 115, 120 dB peak.
Right, exactly. A reader posed a related question here that I wanted to get your opinion on. It's not from the chat room, but it was from an email I got. And he asked, is there a problem with running a solid-state amplifier without a speaker load attached to it? That is essentially an infinite load across the output.
There should not be.
Okay. If it's well designed,
they should be unconditionally stable. In fact, when we're testing amplifiers, that's usually what we do. We usually have them unloaded, and so that when we touch the load on, if we start to smell something burning, we can take it off rapidly. It's a sort of fundamental thing you learn in the lab. Don't have everything wired up, otherwise another prototype will go up in smoke.
What about tube amps? I was told that by somebody who I trust that tube amps are a different story, that you don't want to run those without a load across the output.
Well, I don't recall ever blowing them up. I mean, tube amplifiers, if you think about it, are much more difficult to blow up, as I recall, than transistor amplifiers have the rather nasty habit of failing very quietly. Usually a tube amp, you'll smell something. I don't know. I don't claim to be an expert on tube amps, and it's probably 40 or 50 years since I actually used one. But when we were at CEF, we used to sell Radford tube amplifiers for use with the BBC monitoring speakers. They didn't seem to have any trouble whether they were loaded or unloaded.
Okay. So one application that I can certainly see for these little amps that you're working on is powering each driver in a multi-driver system, be it a three-way or a line array, as you alluded to earlier, seems to be an obvious application, eh?
Well, it is. I mean, it's been the loudspeaker designer's dream for years to have bi-amplified speakers and have active crossovers, but it's been a really slow journey. I would say I can think of probably only one major company that's pursued this route, and that's Meridian in England. They pursued it, a very lonely path for many years, and they managed to create a good brand doing it. I think what's opened the door to it now is the rise in popularity of multimedia speakers, where almost inevitably they have to have an amplifier and low-level equalization because they have to try and make them flat or to extend the bass. And certainly subwoofers have been powered speakers probably for 15 or 20 years, I would think. It was
Sure.
So it makes sense. It's not so easy to do, though. One of the things that people don't realize is that the fact that you are just feeding the amplifier into a speaker, into a tweeter, for example, might lead you to believe you don't need such a big amplifier. And the fact of the matter is you need exactly the same voltage swing as you would if you had a passive crossover in. So that you do need 3 100-watt amplifiers for it to sound as loud as a 100-watt amplifier. I don't mean that it's delivering 3 times 100. I just mean you need that voltage swing in each frequency band. So that's not so obvious. And I remember at one time people thought, oh, well, it's a tweeter. We only need a 5 or 6-watt amplifier for that. And of course, inevitably what happens is you run it into clipping and the thing sounds really quite bad.
This is something I try to impart as often as I can, that, pardon me, that you really want more power from the amplifier. You want the ability to produce more power than you actually need, because you don't want to run into clipping. If the speaker tries to draw as much power as the amp can possibly deliver, then you're going to strain that amplifier. You'd rather have the amplifier working in kind of its middle range most of the time, don't you?
Yeah, I think one of the problems we have here is with the use of the term power. Power is actually a pretty pointless thing if you think about it. You look at a socket, a line socket on the wall, and you say, what is the power of that socket? You never talk about that. You know what the volts are. And with an amplifier, by and large, they're a voltage device. And the only question is, when you turn it up, can it deliver enough amps into the load? The power that goes into the load is just a notional one. They use a standard load, and they say 4 ohms or something like that. It's volts. Can I deliver those volts? And if I do, will it deliver enough amps or not sag because of the power supply or something like that? So, and once you get used to that idea, you realize the tweeter has very, very low average power, but the peak in a short burst is it could be as high as 100 watts for milliseconds or something like that.
Right. Web 988 in the chat room is asking, can the room only hurt the sound, or could it actually improve the sound?
I think it's pretty much agreed that the room does improve the sound. It's this topic is covered very well in Floyd Toole's book that he published about a couple of years ago, that I think you can now get on Kindle actually, or on the iBook reader. We do actually, and if a moment's thought will tell you that this is so. I mean, you sing in the bathroom, you don't sing in an anechoic chamber. There are the room. Good rooms can make useful contributions, and they give a sense of spaciousness and so forth. They put some air around the music, as it were. So dead rooms are just really for doing dead recordings, if you want to do mixing or add some echoes and so forth. It is a good thing to have. It's not a bad thing at all. Anybody who's tried playing in a band out of doors would also agree with this. If you really want a bad gig, play out of doors or in a tent where there's no reinforcement.
Yes, exactly.
And there's no bass. It goes straight through the walls.
Right. Web 988 also says the idea is to eliminate...
Rooms are a good thing. One of the interesting things that he did say, though, which I think is sort of pertinent to this, is that as human beings, we listen to the room and then ignore it. So you and I are sitting pretty much stationary in a certain environment, and we're able to actually tune out, to a large extent, the local acoustics, even though you may not think so. We actually learn just to listen to the things we want. We have 2 ears and we have a brain, and we can hear things that a microphone doesn't, or maybe a microphone sees more than we hear because we're used to listening within the room. So that notion of adapting means that there are no really hard and fast rules about rooms at all. What Floyd also showed was that when you evaluate speakers in different environments, contrary to what we all thought 20 years ago, you don't rank order the speakers in a different order. You may give them lower marks, but the best speaker generally sounds the best speaker in all different rooms, and it is because we have this ability to listen through it, listen through it, and then ignore it. We really underestimate. So the question of room equalization the extent to which that can be successful really is something we should think about, because the microphone doesn't have this learning process. It goes in and it measures just one thing. There's no doubt you can do equalization in a room at the lower frequencies, maybe below 100 or something like that. But at the middle and high frequencies, there's really no substitute for making the speaker as good as you can before you ever get it into the listening room. If you had to do that, there would be something funny with the room. So I think it's a point for discussion, and I don't know if you're like us. We have measured a lot of these equalization systems, and they all come up with vastly different answers, which itself has to be a little bit suspicious, doesn't it? And,
I agree. It has to be very suspicious.
If the room hasn't changed, why does the EQ change when you haven't changed the speaker? So my view is judiciously used for middle and low, for low frequencies. Certainly, it's a good thing. Above them, there's no substitute for having a speaker that has a pretty smooth on-axis response and varies only smoothly as you move on to different axes.
Yes, indeed. Sandman in the chat room wonders back about the amplifier we were talking about a minute ago. Is this similar to the Carver magnetic amps of the past?
Well, in one sense, in terms of the philosophy of the design, what Bob Carver was trying to do, which I always thought was very sensible, was he was trying to make an amplifier that would deliver a signal to the speaker more in line with the demands of program rather than of sine waves, and to that extent, I think it was a really good idea. This is. It bears some similarities, but it is essentially it's a error correction, and it has tracking power supplies. That's how it works, but with particular attention paid to how you keep the standing or the bias current down to nearly zero, but at the same time you don't have problems with crossover distortion. So that's essentially was the tricky bit to solve, and that took quite a while.
These are full range amps, right? They cover the 20 to 20K range?
They go yes, they go up much higher than that. I'm trying to think. This one probably goes up to. We can set it where we like, but it can go well in excess of 100K if you want to. In other words, the limit would be generally the program material rather than the amplifier. There's no problem with making it stable, certainly up to 100K or something. Is that useful? Well,
that's the next question. Exactly right.
Well, no.
There are speakers, tweeters that go up to 40, 50K at least, right?
Yes, there are, and there are people who are recording music and claiming they go up to well above 20K, but not if you're sampling at 48K. You'd have to be higher than that. But in general, most switching amplifiers, for example, will have a filter on them. They have to have passive filters on to keep the switching frequency out. And it's not that the switching frequency is audible, but it's quite conceivable you could have cross products getting down into the audio band. So when you test these amplifiers, you quite often run into funnies as you go higher up the frequency range.
Right, exactly.
Look, I think the answer is if you've got it, flaunt it,
Well, the real question for me is, can these speakers that produce 40, 50K and amplifiers that can reproduce it, and maybe there's, say, a 96 kilohertz original sound file that's reproducing, say, 40K, can you hear it, or can you hear its effect?
Well, it is claimed by some people, and I don't claim to be an expert in this area, that having a higher sampling rate allows you to be less aggressive with the anti-aliasing filters or the reconstruction filters in the DAC. And there is some logic in that because, even though it's digital, it isn't perfect. There are always design considerations. I think there is a case for going at a higher sampling rate, even though the bandwidth of the music isn't that high. I mean, there's very little material that goes up to 20K. I did experiments some many years ago at the AES in England, and pretty much people could not hear filters going in at 20K. Quite a few of the people could hear it at 16K, and everybody could hear it at 10K. And we were having to use an artificial test signal because we couldn't have a digitally recorded program because it was already band limited. So
right.
Really big. I don't know. I believe intuitively that it's what happens in band that's much more important. The really good sounding speakers like the quad electrostatic, for example, that didn't have a very, very extended high frequency response, particularly off axis, but it did have a sound character that just seemed so natural. And it could do a job with human voices that I've seldom heard on a moving coil speaker, and no matter how hard I or anybody else has tried. There is something about, and I think it's because they didn't have a box. The box is really the biggest hold-up with most speakers, because it vibrates. It refuses just to stand there and look pretty. It insists on imparting a character as if it was a musical instrument, and that is an issue.
Which the electrostats don't have because they don't have a box.
They didn't. They actually couldn't work in a box because they represented a transparent window. So he was making a virtue out of a necessity. They were also a dipole, which meant as you put them closer to the wall, you got less bass rather than more, as you do with a moving coil one. So they were brought into the room. So for all sorts of reasons, I think it was that they suffered really only from one thing. They were a bit directional because the size of the panels were quite large. So you really had to have them pointing towards you. That was quite a key part.
There's one question in the chat room here. Otto asks, so horns use less power than cones at the same volume?
According to the textbooks, they do. But if you actually measure the efficiency of a horn, you'll find it's only efficient at quite close to the cutoff frequency of the horn. At higher frequencies, they will need equalization. So, yes, over a very narrow band, they will indeed be more efficient. But over the broad band, they're not so efficient. No. And of course, they have other problems, like they have a horn, and the horn itself needs a lot of care and attention if you're not going to hear that. So it's very important what you make the horn of, and they need to be very well damped. There was an electrostatic driver that was made for a horn. It was in the AES. It was by Professor Joseph Mehrholt from Czechoslovakia. And this was the most splendid device. It really did work well. So that restored my faith in horns. It's not the horn that's the problem. It's usually the combination of the driver itself, which can be not very nice, and the structure of the horn, which was quite often made for strength rather than from being dead.
And yet most commercial cinema speakers use horn tweeters, don't they? Yes,
they do. I think it's really a throwback to the time when cinema sound first started. They only had a few watts available anyway. I mean, movies started in, sound was in 1926, 1927. Feedback audio amplifiers hadn't even been invented then. And so they were looking for a watt or so being enough to fill a cinema. And but I would say that you can do a better job now with multiple smaller drivers. I would say that, of course, but I believe you can. I think that is the right way to do it, and it'll just be a matter of putting it to the test. If it sounds better and gives better coverage, then people will say, I like it, and if they don't hear a difference, they'll stay with the status quo.
Yeah. Of course, it would mean that theater owners would have to replace their speakers, and they're not going to be likely to want to spend that kind of money.
Well, I think that's increasingly true in the cinema. On the other hand, if you're going to get people going back to the cinema, there's got to be more than an overpriced bottle of something to drink or something from the concession stand. I mean, there has to be more of an experience if you go. It has to be very different from anything you could have or see at home, and I think that really is the key. I believe that sound is trailing the pictures now. I think with the advent of digital cinema and so forth, that we do need to distribute sound in a better way in the cinema, and it maybe arrays will form part of that. They can give better coverage, particularly if you're not directly in front of the speaker. Most of the sound in the cinema comes from the center channel and from the subwoofer. But when you're well off axis, you're really hearing a sound like that. I mean, you're well away from the optimum axis. So I think better coverage in the cinema. Plus, of course, the ability to have more uniform sound levels. Typically, if you're very close to the screen, the chances are it's going to be really loud, and if you're at the back, it's going to be quite a lot lower level. It's possible with arrays to get very uniform distribution front to back as well as side to side. So it could be that that's going to be interesting.
Well, I want to talk about arrays in a minute here, because that is another thing that I know you're working very much on. But before I get to that, I would like to take this moment to thank our sponsor for this episode, Netflix.com, which, as we all know, streams thousands of TV episodes and movies instantly to you, saving you time, money, and hassle. You can watch Netflix movies and TVs on your TV shows on your TV, your Mac or PC, even your iPad, smartphones, Xbox 360, other gaming consoles, PS3, Nintendo Wii, Blu-ray players. I mean, you can get Netflix from just about any AV product these days, which is quite remarkable if you ask me. And you can watch them instantly on any of these devices, and you can begin watching on one device and finish on another even. Whichever way you choose to access Netflix, you can watch as many as you want for one monthly fee, as any time you want. And you can cancel any time if you don't like it, but who says who would not like this? I like it. I use it all the time. To try Netflix today for 30 days free, go to netflix.com/twit. Be sure to use that URL when you sign up for your free trial. netflix.com/twit. And we thank Netflix for their support of the Twit Network, and we sure hope you enjoy watching all of that great content instantly. So, Laurie, we were going to talk about speaker arrays, and you mentioned that this might be one way to improve the sound quality in commercial cinemas, and perhaps even in the home as well. And I know that you've been working on this for a while. Why don't you tell us where you're at with that project?
Well, an array is there are a number of ways of thinking about an array. Most people think of it as a form of line source, but what they really are is what you're doing is you're taking a snapshot of the sound further away and creating, in this particular instance, we're creating a two-dimensional array is essentially what we do. And typically what you have to do with that is you have to curve it. So if you want a broad response, and you can curve it either physically by bending it in a shape of an arc, which is sort of fairly intuitive, or you can do it by feeding each of the speakers separately and putting a delay on. So effectively, the one in the middle reaches you first, and the others are delayed, and so you can bend it. You can bend it in that sense.
Effectively bending it.
Yes. And if you have it horizontal, the point about an array is that its directivity in this direction is determined entirely by the shape that you put on it. Vertically, in the opposite direction, it depends only on the directivity of the drive unit. So if it's a fairly big one, it'll be as directional as that was. So that's the fundamental thing. You can have two dimensions, in which case you can change the sound in two directions at once. Quite a bit more expensive. I mean, a line array with 100 on is sort of a go, but you have 100 by 100 and you've got a few amplifiers there, 10,000. That's probably not going to fly, even with me. So typically, though, what I've described is changing the directivity. So essentially what you can do is you have a speaker that has a very broad response or a very narrow response. The longer you make the line, the lower the frequency that you can control the directivity. We've got one that's about 2 meters long. You can control that probably down to about 150 hertz, but I could make it longer. The controlling at high frequencies is much more problematic. In the same way that you have aliasing with audio, you also have what they call spatial aliasing. So in order to go up to very high frequencies, the drive unit's got to be very close together. So if you wanted to have a truly directional array up to 20 kilohertz, the drive units would have to be something like 3/4 of an inch apart, and that's pretty difficult to do. And now bear in mind, this one line has to produce bass and high frequencies. So the way we've got round this is we make a two-way line. We have a line of tweeters, which are as close together as we can get them, and then we have bass speakers, and we cross over at about 2 kilohertz. So that's the first thing you can do with a line. Then if you want to, you can apply some, so if you have a separate amplifier for each one, you can not only change the beam width, but you can also steer it. So you can think of these like lights. This is like changing from a spotlight to a floodlight. Being able to steer it is like having a searchlight, if you like. You can aim it in different directions. And that's sort of what we were looking at for the living room. And you could do that in the cinema if you wanted to direction it horizontally. But if you turn the line up and have it vertical, then you can do it like that. And that's where it's much more interesting for the cinema, because you can direct the beam intended for the people at the back straight to them, and you can put on delays, and you can have quite a narrow beam facing to the back of the hall. And as you come down closer to the front, you can turn the level down so that you get this uniform coverage. They're very interesting devices. What they allow you to do is to make a speaker with a speaker system with a predetermined directivity at all frequencies. At the moment, you're pretty much stuck with the fact that the bass speaker gets more directional, it gets to the crossover, and then it opens out again and does that. And that's really hard to do. You can do a little bit with waveguides, but there are problems with waveguides, rather like horns. Once they get quite large, it's difficult to get them close together. So then you want all the sound to come from one spot, one common concentric point, and that's very difficult to do.
Well, so that was the design philosophy, I think, behind what am I thinking of? The Kef Uniq, and the Tannoy also made a dual concentric, and other systems also purport to have an array of some sort whereby it sounds like everything's coming from one location. The new Kef Blade, for example, you saw that at the CEDIA show, I'm sure.
Yeah.
They have what's it called? A single coherent source, SCS.
Yes, well, that's an adaptation of the old Uniq. They've just done some mods to the center part, how the tweeter works. And what really happens with a concentric speaker is that when you're using a bass speaker at the upper end of its range, it isn't really, the whole area is not radiating. Pretty much what's radiating is a little circle just slightly bigger than the dust cap. So everything's coming from the middle. And if you put a tweeter right in there, what will happen is that the cone will impose its directional characteristics on the tweeter. So in the crossover region, they have exactly the same directional characteristics, about an octave either side. So it's a useful thing to do, but it's so unusual that you have to learn different ways of balancing the system, because typically you don't listen to a speaker on axis. I mean, I don't know about you, but quite often they'll face directly up the room. There may be visual reasons why you can't cant them in and so forth. So normally we're 15, 20, maybe even 30 degrees off axis in typical listening conditions. So you then have to determine whether you're listening to the direct sound and the reflected sound, and the answer is you're listening to both. So what is the mix? So that's where the art comes into speakers. You can't just say this is going to be good. You do have to listen to it and compare it with live sounds.
Sure.
But it's a useful thing to do, and it's definitely worthwhile. Arrays simply take that to another level. You can do it, and you can steer it, and you can do lots of things at once. You can use superposition, where you can have the array pointing here, here, and here, all at the same time in 3 different places at once. I'm not sure how useful that is, but we did it where we had 2 people, we had music and somebody talking at the same time, and you can put out 2 beams, like one to the right, one to the left, and you walk over and you can barely hear the other sound. It sounds like somebody speaking in the next room.
Yeah, I actually heard that at CES last January, and it's remarkable.
Yeah, it actually works really well. In the end, what limits what you can do is the sound bouncing off the walls. So, but because you know where the beam is facing, you could always make sure there was a diffusing surface like a bookshelf, or that there was a curtain or something like that. So you can make sure you didn't get that false image of the reflection off the wall.
Floop in the chat room asks, how is this system different from Don Keel's CBT array in its time delay incarnation?
Well, Don Keel was the man who was really responsible for rediscovering this a constant bandwidth transducer, so-called. Originally, it was developed for underwater sound, I think maybe in the middle 70s or something like that. He recognized its application for arrays, but the way he did it was he actually curved the arrays, so he physically put the delay on. But once you've done that, you fix the directivity. There's nothing much you can do about it. What we did was we did a couple of things. First of all, we did the shading, that is making the outer ones lower by feeding each one with a separate amplifier, which is much more versatile, and we as it were bent the array by using delays, so we could actually have controllable directivity, and we could also move the direction. So his was more of a passive one, if you like. It could be active, but he didn't do that. I think they had originally an idea to do it for the cinema, but he's the man who should take the credit for bringing that to everybody's attention, and there's no doubt that particular weighting function is far and away, well, in my opinion, it's far and away one of the easiest to use. You don't have to do anything very elaborate with the EQ. It's just delay, and that's all there is to it. You have to make sure it's correct delay, but you just delay and you change the magnitude. So the middle one is the loudest, and it goes on, and the outer one's probably a 12 dB down or something like that.
So that's how you create beams and steer them, is with variable delay on each of the drivers in the array?
Well, we first of all make it a curved one. I'm looking at the thing sort of from above, as it were. I can curve it like that. In order to steer it, of course, what you have to do is you have to advance the left-hand one and delay the other one. So you apply a sort of like a seesaw thing. So the one, let's say, on the right-hand side, you delay the outermost one, and on the other one, you bring it forward. Of course, you can't bring the sound forward, so what you're really doing is having no delay on this one and twice the delay on the other. But you can do it, as you heard, real time. You can swing it through. Creating the delay is quite tricky. You can't just use the sampling interval. You have to go in the gaps. So we delay with an accuracy of about 1 microsecond. So there's quite a bit of extra processing to do in there.
Mm-hmm. And that's not in the amp, is it? That's in a separate processor?
That's all separate. The amplifiers are one part. We drove it all with, we used the DSP library that runs on, the Intel DSP library that runs on a reasonable sized machine. It doesn't have to be huge. It can run on a Pentium 4. We can do 90 odd channels on a Pentium 4. And the most we've ever planned to do is 384 channels. You could probably do that on one of the new machines. You could probably do it all on the same machine now. It's just the data rate.
I assume you've heard of and maybe even heard the EOSono system?
Yes, I have, actually.
That's another array.
It's a very ingenious system. I think it's French. Oh, no, sorry, I beg your pardon. I'm thinking of somebody else. That begins with T. EOSono is the one that was done by the people who did Fraunhofer Institute.
Fraunhofer, yes, exactly
in
right.
Germany. And they had, what they had was lots of small two-way speakers. But, of course, the problem they had is that they were spaced, they were long enough to do interesting things at low frequencies, but they were much too far apart to work much above about 1500 hertz or so. So they really couldn't do the high frequencies. And that is true probably of most of the big arrays you see on the market, which are really primarily concerned with sound reinforcement. So they give you a really strong forward beam so that they can get some carry in difficult acoustic environments. But I don't think anybody's made one go as high as we have. It's just a matter of doing it. I mean, you've just got to want to do it and have the time. Yes.
Right, and the resources to put those, as you say, the tweeters really close together, which means a lot of them.
Yeah, well, the thing one has to realize is you may only want one prototype, but it's like building 100 prototypes, because when you're wiring up a 60 or 70 tweeters, believe me, you have to be really careful about what you're doing.
Yeah. Is there any thought of commercialization of the work you're doing now, or is it still just in the research and development stage?
Well, really, when we do things like this, we're really showing people perhaps the importance of being able to control directivity and so forth, and we would look to them essentially for whether it's of interest. It's a moot point, because so much of what is called R&D now isn't really R&D. It's really about sourcing in China. Very, very few companies in audio still maintain a significant R&D basis in the US. The business simply won't support it. So increasingly we found ourselves having to make something much closer to a production device to show to people, because then they can see for themselves what it might look like and how much it might cost and so forth. But it's fairly esoteric. I mean, it's not going to be cheap, so it would be a high-end system for the home, or, as I say, something new for the cinema. It could have uses, actually, interestingly enough. It could be useful in recording studios. I think that's a really good, because we all know in recording studios you've got the guy doing the mixing. He's usually sitting in the worst spot in the room, right in the middle, where there's no bass. And then the person who's paying for it is next to the bar at the end of the room, and they're hearing different sounds. And so if you want to hear what's being recorded, what the mixers are doing, you need to go and stand behind them. Well, here, at least in theory, you could send beams that were equivalent to more than one listening area, and that could be worth doing, I think. But that's not a huge business. There aren't enough recording studios to make that a mass production line, that's for sure.
Yeah. Floop in the chat room asks, can you explain the patent application for surround system with left-right cancellation scheme? I don't think I know this. Do you?
This is the one we did. We did originally for automotive. Well, there were two applications. One was for a surround speaker at the back. I don't know whether you remember when THX and Dolby came out at the same time with the idea of putting an extra channel at the back of the room. And,
yes, it was called THX EX.
Yes, and then it became Surround EX. I'm not sure what Dolby call it now.
Yeah.
But essentially, what I was concerned about is if you put two speakers at the back of the room behind you, of course, it'll be like listening to stereo. If you're sitting one side of the room or the other, which is very likely when you're watching a movie, it's very rare that you just sit in the middle. There's usually a group of you. What you would hear is just the left or the right one, depending on where you were. So what we did was I said, well, supposing we put the two close together and we used an image broadening technique. It's a technique that was used by Michael Gerson spoke about it in the AES journal. It was based on a thing called a Blumlein shuffler, which is actually a microphone recording technique, and we just converted it to work with speakers. If you put two speakers very close together, then what you can do is by using cross-cancelling, you can get a broader image, but over a much broader area. You can have image widening systems now, have two speakers, and you can make them wider, like Polk did with these speakers or others have used. But the problem with that is it only widens it over a relatively small listening area. If you put them closer together, then you can make the sweet spot very broad. The problem is when you put them close together, the low frequencies are cancelling one another, and so you have to boost the low frequencies, and that presents some challenges in doing the EQ and so forth, but you can do it and make it sound, and so that's all it is. It's just you feed a bit of the left into the right, a bit of the right into the left, and in anti-phase. But there's a little bit more.
If they're out of phase, though, then they're canceling. Doesn't it make sense then that no matter how much you boost the bass, you're not going to hear any more of it because it's just going to get canceled?
Oh no, it won't get it because. Typically, the signal in the left and right, they must be quite similar to produce a stereo image, because let's face it, what you hear with this ear and this ear when you're listening to something is a slightly different version of the same sound. Let's say the sound was over here. This ear is going to be more or less on axis than the other one. It has to come round your head, so it's delayed a bit, and it also loses some of the high frequencies because it has to go around your head. So
it's filtered,
you perceive that sound as coming from there because you're hearing a low-pass version of the other one. The problem nowadays is that there's very little stereo that's recorded. Stereo is really a two-microphone pickup of a single object in space. What so often happens in recording is that they're all separate tracks and they're simply pan-potted in position. So there isn't necessarily anything of the left and the right. They could be completely separate ones. So sometimes you have to introduce some deliberate crosstalk to simulate what we would be listening to in a room in order to get this image broadening to work. But it was done originally for the surrounds, then we did it in the front of the car on the basis that the center speaker in the car is always off axis of both people. So you can either have it perfect for the driver and completely wrong for the other. I wanted to make it a little bit more diplomatic, that the left and right person could hear more or less the same sound. I'm not sure in retrospect how important that might be in practice, because of course normally 90% of the time there's only one person in the car.
Right. Well, before we finish up here, I did want to spend a little time talking about the new soundbar certification program at THX, which I know you're involved in as well. And soundbars are becoming very popular these days, particularly as a replacement of the TV's own sound, right? You buy a TV these days and you've got the two really crappy speakers, really bad amplifiers. It sounds really lousy, and people maybe don't want to put a full surround sound discrete speaker system in their theater, so they get a sound bar. And I think this is definitely a step up, but there's been a wide range of qualities in sound bars too, and THX is just, I think recently at CEDIA was the first I heard of it, announced a soundbar certification program.
Yeah. Well, I mean, essentially what it is, it's a left, center, and right speaker. Instead of being stood up like soldiers, they're all turned on their side. So really what you've got is you've got the three speakers, but now they're on their side. If you take a typical loudspeaker, which has, say it looks like this, and the tweeter's here and the bass speaker's there, when you put it on its side, the directivity becomes quite poor, because instead of it being the up and down response of the speaker, it's the side to side. So the hardest part for the soundbar was, first of all, to get the directivity that you wanted in the speakers where effectively they're on their side. That's the first thing. Secondly, is soundbars were usually done as part of a cheap home theatre in a box system, and so they were trying to minimize the amount of material, so they would sound bad because the drivers weren't big enough, because the enclosure wasn't strong enough, and so forth, and also because probably they didn't have enough power. So what we did really is we took one of our specifications and said, okay, we're going to turn it on its side, we will now set a specification that can be achieved, but you've actually got to do it properly. And one of the first and the best that we saw was from Teufel, who are in Germany, and they did a really good job on the soundbar. And it's just a matter of wanting to. There are non-powered ones, passive ones that are made by Polk and people like that, and they make some quite respectable ones too. But essentially, as I mentioned earlier, when you have a small speaker, you're absolutely dependent on having it powered, because you're going to need to EQ it to get the response down to the sort of frequency you want with that size enclosure. There's not much volume in a small tube like that.
Yeah, true enough.
You can't really have, if you think about it, with the early multimedia speakers, you'd have people putting two on the desk here. Where do you put the other one? Do you put it here, or do you put it down there? And if you do, it draws attention to the fact they're not in the same line. What's so curious about, and you can do this experiment for yourself, is when you're watching a movie on television, which typically is what a soundbar is used for, you will find that the ear and the brain always make sense of what it sees and what it hears. So, for example, I had a system at home where I was just getting my big screen working, but my audio system was in the corner of the room. And so I said, I'm going to play this now. And somebody said, well, you're going to hear the voices coming from the corner. But it isn't like that. Eventually, what will happen is the brain said, the lips are moving here, therefore the sound is coming from there. So you can do it for yourself. You just put a speaker over there and just watch a voice, and I guarantee you, in the end, the sound will come from where it is. So the actual position of the center speaker isn't. But for music, of course, you can't do that. You're in no doubt the music is coming from the corner. But for the voices, the brain just says it's coming from there, and so it is. You know.
That's amazing. I'd never heard that before.
So you don't have to fuss quite so much about, a lot of this is in the mind. If you think they're here and here, you think logically, oh, that's not going to be correct. We just put the voice where it seems to be coming from. I noticed it first when I was on the plane, and I had headphones on, even though dreadful headphones, and I was watching this screen up in the air there, and I suddenly realized that I'd stopped listening to the headphones and imagined the sound coming from the screen. And so the brain doesn't like to be confused, or it doesn't like to have to battle. It likes to take control. If that's where the picture is, that's where that piece of information is coming from too.
It reminds me of the experiments that have been done where people who wear glasses that say invert the image and makes everything look upside down, after some period of time, everything looks right side up to that person. And when they take the glasses off, everything looks upside down.
Yeah, well, I mean, we're learning so much more about the brain. I think that's one of the most interesting aspects of MRIs and so forth, is you can actually see the brain working now, and we're beginning to understand a lot more. And what we do know now is we didn't know much before. we know a little bit more now, but the idea of the brain readapting itself is I think an interesting and a very encouraging one. So you can get people with brain damage, and you can actually relearn how to use your brain just because you have to. It's a matter of training, but I think that's very reassuring.
Mm-hmm.
But it is back to the earlier points about EQ and other things that we do. You have to be very careful that the things you equalize are the things that you always hear in the same way. It isn't a function of time. It has to be something that you cannot ignore, and then you put it right. That certainly would be true of boomy bass in a room, I think, for example. But some of the stuff you need the courage, even though you see it in the measurement, to leave well alone, because we're not listening to it the way a microphone measures it. And that's probably the hardest part to learn, is to just behave yourself and not fill in every dip with a peak, or every peak with a dip, or something like that.
Please behave yourself.
You've got to ignore the things you don't hear, and that's a matter of being observant, and being honest with yourself. Say, did I really hear that or not? There's still going to be plenty of things you can hear that you can't see. So there's plenty to do.
Dr. Horstan in the chat room asks if THX has any plans for a surround headphone specification. Again, it's really about tricking the brain.
Yeah, headphones are a really tricky one, because whatever you say you're hearing on your phones, I have to believe you. I have no means of sharing that experience with you. I can say that I did hear one, which was done by the Smythe brothers, who were the original people with DTS. Amazing piece of work they did, and they go in and they measure all these transfer functions, and they put this, I think they were stacks electrostatics, but really convincing job of making sounds come from where the speakers were in the room, and that was extremely well done. But it was quite complicated to do, and it practically wanted a PhD to go in and take all the measurements and set the thing up. but that it works, there is no doubt. The question is, could you come up with another way of calibrating somebody other than sitting them down for 3/4 of an hour while they learnt where everything was? So it can be done. But I don't think it's just going to happen on a regular pair of headphones. Plus, of course, you have to have a device on there, a compass or a gyro or something that knows which way your head is, because you don't want the sound to move with. That's the biggest clue to headphones, of course. As you move, the sound moves with you.
Yes. And their system does have a thing on the top of your head, a head tracker, that keeps the apparent position of the speakers that you're quote-unquote listening to in the same location as you move your head.
Or put your head in a vice, that would work as well. Probably
that would work.
Although, to be truthful, we do in fact need more head movements in order to reconfirm the space that we're in. So you need a certain amount of that to know where something is.
What about Dolby Headphone, which was originally developed by an Australian company called Lake?
Yes, it was. Yes, I haven't really seen too much of that. I think with all these things is maybe it isn't interesting enough to enough people. Maybe it's just very expensive or very complicated, or maybe it's a variable experience. You know, there are some people who claim they hear sounds out of their head with headphones, and other people who say it's always here, just on the top of my head. And maybe it is. Maybe the compensation that some of us have that makes sense of what we hear is not present in those people, and I don't know how you prove it. You know, If you say you hear it out of your head, then you do. I think the surround one is it's moving. The problem with headphones isn't having stuff moving in the back hemisphere. That's actually quite easy to do, and has been well documented. It's getting it to come out in front of you, and a lot of the time, what happens is you get ambiguity: is it in the front or is it in the back? And that's been one of the biggest single criticisms of headphone systems, that the sound sort of goes round in a circle behind you and then goes over the top of your head instead of going out in front. An image in front of you would improve that. So if it were for games or for watching movies, then I think the likelihood of you getting an all-round effect is probably much greater, because it will make sense and say, well, even though I know it's not coming from there, I believe it to be coming from there because that's what I see.
Mark from San Jose asks a somewhat different question, and we're running out of time here, so just want to slip this one in if we can. What is the process of selecting the drivers in a line array so that they are sonically matched? For an LCR setup, left and right speakers will be upright, but the center will be on its side. How do you correct for this in the sound staging to make the sound acceptable?
Well, there's two things there. There is no substitute for going to a good drive unit manufacturer. That's one of the things you have to do. We do have the ability within our software to equalize each one to make them absolutely identical, and we have different filters for each channel. But typically, if you go to a good manufacturer, you will find over a quantity run, which might be a day or 2 days or something. Typical line will do about between 1,000 and 5,000 drivers a shift. They will be extremely consistent. If it's a well-designed transducer, by that I mean it doesn't have any very sudden changes in frequency response with frequency, peaks and dips, that helps too. Tweeters in particular, there are very few companies that make really consistent and good tweeters, and almost all of those come from Denmark, or did originally. I don't know why. It must be something about the weather, or the schnapps or something, but they make really consistent tweeters. It's a matter of always making it in the same way and treating it in the same way. Now, the other part of the question was the vertical and horizontal characteristics of the line. Did I hear that right? Was saying the the left and right speakers will be. You were talking about verticality and horizontality. I would do it with a single horizontal line. That's the way I would do it, and not actually have one standing up at the side. Funnily enough, but the first line arrays we did were in fact vertical ones. They were like this, and they came out of the slot that we developed, and they were extremely broad horizontally. And one of the funny things that we discovered with this is you could go right up to the screen and put your nose on the TV screen, but because they were so omnidirectional, the image stayed absolutely in the middle because it was omnidirectional. So you can create the center image by the left and right there, but with this one, that you actually have a real image. So I think horizontal is probably the way to go, and that works just fine. The one that we had, you could actually make sublines of lines. If you recall, it had a lot of drivers, but you could choose this lot here, and you could have a speaker here. So you could have a speaker every inch or so if you wanted to, composed of 5 or 6 adjacent drive units. So when you move off axis, you don't have the stereo one where it swings to that speaker. It's a real source there, so it's absolutely locked in there where you get the right mix between them.
Great.
But it is complicated. And I don't want to wire another one up, not at 3 o'clock in the morning.
Well, okay, I won't. But we've come to the end of a fascinating hour, and I want to thank you so much, Laurie, for being a guest here, and for, in fact, being a guest from the Twit studio there. It's got great video and audio, and I sure appreciate your going over there to join me today.
Well, it was my pleasure, and I enjoyed it too.
Thank you so much.
Cheers.
Of course, you can read about what Laurie's doing and everything else, THX at thx.com. My online homes, of course, are hometheater.com. You can email me at scott@twit.tv, and you can follow me on Twitter at htgeekscott. Next week, my guest geek is scheduled to be Paul Barton, the P&B of PSB Speakers, the founder and chief designer, where we will talk more about speakers, more specifically about headphones, his first foray into the world of headphones, which I heard at CEDIA, and I was very impressed. So I sure hope you'll join me for that. Until then, geek out.